This is StarTalk.
Hello and welcome to StarTalk. I am Dr. Natalie Starkey and this is StarTalk All-Stars. I am going to be your All-Star host today, and joining me as a co-host I have comedian Chuck Nice.
Hey, Natalie.
Woo, thank you.
Good to be with you again.
Yes, it's going to be fun, I think, because today we are going to be talking about water in space. I want to just stress that I'm saying water. I'm very British.
Exactly, water.
There's a T in the middle of water.
Not water.
Not water, no.
You're not having water.
We are actually talking about that as well.
We're talking about water too.
Thing.
Okay.
Yeah. So
talking about water too.
I guess I want to talk about this subject because it's quite important, right? We drink water all the time. We drink liters of it.
I'm going to say that water is indeed the most important substance on Earth ever.
Okay, you said it. Okay.
Seriously, I really believe that. There is nothing more important than water. I believe that is where the origins of life stem.
Okay.
I believe that that is why it is the most necessary thing to sustain life. So it is where life began, and it is also where what sustains it. And for some reason, we don't treat water like it's important.
We need to respect the water.
Respect the water. Respect the water.
You are so right. And it's a bold statement, but I think, it's fair enough. We do need to respect, but we need to understand where it came from, because it does appear that Earth is the only planet in our solar system that has liquid water on its surface. Now, it's not to say there isn't liquid water elsewhere, but not on the surface of any other planets. Right. It's probably ice. Now, there's loads of water in the solar system, but it's probably as ice. Now, importantly, we think we need it as liquid for life, to start and form and everything. So why are we the only planet with liquid water? This is one of the big research questions, and one of the questions we should be asking.
I'm going to say it's because we're special.
We are special. We are very special.
I think we're special. I mean, just look around the solar system, okay? We're pretty damn special. All right? Take that, Venus.
There we go.
With your hot climate surface.
Exactly.
Right, okay?
Crazy hot.
Yes, we are basically the Bahamas of the solar system.
Okay.
Think about it.
Place you want to be.
It's the place you want to be.
I like that. Yeah, it's true. So, okay, to help us with this subject today,
yes.
We have a world expert on water in the solar system, and it is Lindy Elkins-Tanton. Welcome to the show.
Hi, thank you so much.
That's all right. We're really glad you could join us. Now, I'm going to get this right. You're the director of the School of Earth and Space Exploration. Is that correct? At Arizona State University?
That's exactly right.
Okay. And what does your job involve? Just directing people around the university?
You over there, pick that up. I'm Director Lindy.
Remind them that we're living in the Bahamas, basically. That's what I do.
Okay, that's good.
No, I serve, right? That's what directors do. I try to make it easier for the scientists to do their jobs and answer their big questions. And a lot of people here are working on questions just like what you're talking about. Why do we have water here? Why is there not liquid water elsewhere? Why is the Earth not Venus? Thank goodness.
Thank goodness.
Very cool.
And your own research, I mean, you've got a background in research as well, and that's what you've been looking at, right? You've been looking at this kind of how we get water on planets and all this business. So you are going to be quite helpful, I think, because today we're going to be looking at cosmic queries and trying to answer some questions from the peoples out there about this subject. So I think we should probably kick off and see how we go.
Yeah, let's jump right into the questions here. And I'm going to take one from Dylan Hallahan, who is a Patreon patron. If you're a Patreon patron, what you get to do is send us a question, and we will give it priority, because if you're a Patreon patron, it means that you have supported us financially, and you help make this whole thing happen. So it's actually addressed to both of you, Dr. Elkins-Tanton and Dr. Starkey.
Very nice, very formal.
Isn't that very formal, but still very cool? How likely would it be for us to set up a workstation in a Lagrange point?
Okay.
Limit fuel consumption and keep equipment in safe location near the moon, Europa, and be able to take multiple trips to analyze the composition or harvest the water that lies beneath it. Now
Wow.
to start off, I'm going to tell you right now, to start off the cosmic queries with first of all, that's a super packed question right there.
That is a big question.
I mean, that's a huge question. I mean, this question really has more parts.
Got everything in there.
It's got everything in it. It's like a freaking cosmic cake that you got to bake.
This person is too sophisticated. We're going to have to get them to answer their own questions.
Exactly. Before we get into this, let me just ask another question.
This guy knows too much.
Yes, right. Lindy, what is water? No.
I could do that one.
All right, so
okay, we can break it down.
Let's break this down and get into it. First of all, he's talking about a workstation in a Lagrange point.
Well, I was going to start first with the Europa part. Okay?
Well, okay.
I think that's the better way to get into this because
you're the doctor.
First of all, why does he want to go to Europa? That's the big question. What is so interesting about Europa? It is very interesting. Because what we think is happening there is that there is liquid water, but it's not at the surface. It's under a surface of probably water ice. But the fact is that there potentially and quite likely is water under the surface. And this is
and why do we say potentially and most likely? What evidence do we have?
I think, Lindy, am I right in saying it's not fresh water, is it? It's salty, I think. Is that right?
So we think it's salty partly because freshwater is really rare in our solar system, and there we think that the water is actually there's an icy crust and then liquid water, and then underneath that a rocky core, and so the water and the rock are interacting, and when geysers go up from the surface, it looks like they have salt in them. So it's not fresh water, but it still could be good for life.
Yeah.
And when you say it looks like it has salt in them when the geysers, create their plume into space, is that because we're able to we're able to see that in some form?
Yeah, so we can measure that material that's coming off, and so they know that it's got potentially some elements in it that look like it could be salty water. Now, the thing is that planet is kind of sounding a lot like Earth, right? We've got the rocky interior.
I was about to say, it sounds like our poles.
We've got the oceans, and we've got ice on the surface in some places. So it is one of the key places in the solar system that we're wanting to go in the future to actually look for life. But first of all, we need to understand the moon itself a bit more. But this is, I think, why this person's asking this question.
Dylan is saying
this is why we want to go there, and we definitely do want to go there. Now, the second half of the question, in terms of setting up a camp in an orbit around it or something, I guess that is going to be extremely challenging. I mean, Lindy, I don't know what you know about this, but I think that would be. I think first of all, we just need to probably do a flyby, and potentially drop something in so that we can work out what is going on there. But trying to get into orbit around something that's so far away that we don't know much about still would be challenging.
That's right. So first, we're just trying to send a mission that's going to do a whole series of flybys and look at Europa from different points of view. And right away, there's a giant challenge because there is such strong radiation that we don't even think the robotic spacecraft is going to survive for long.
Ooh, wow.
Let alone a person.
Now, that's a huge, huge challenge. So the radiation itself would actually interfere with the instrumentation.
Yeah.
Yeah, we think it'll break down the instrumentation. I heard someone say recently that if you could put an unshielded person on the surface of Europa, they would die from radiation poisoning in a matter of minutes. Ooh. It's that strong.
It's that strong.
Yeah.
Yeah. Right. So I don't think we want to hang around. And NASA always says, you have to limit the number of technology miracles that you require for every mission. And this idea of going and hanging out in the Lagrange point and then zooming back and forth, that's I can't count that high. That's a lot of technology miracles.
That is.
All we need is a starship with shields. That's it.
Yeah, and you know what?
So are you on this? You got this covered?
we can. That's easy. We'll just do that. But in terms of Lagrange points, I mean, I think it's something that we can think about around the moon because this is a body we understand a lot better. And in terms of we talk about asteroid mining, that's one of the ideas. We drag something into low moon orbit, and then we can mine it, and it's a bit easier because it's closer to us. But when you try and extend this out into the solar system, it just gets so much more complex, and we know so little about these objects that it's basically impossible at the moment. But you never know in the future. First, we need to take small steps, like the Apollo mission, small steps,
small
and
steps.
we get there eventually.
So now I'm really fascinated by the fact that the radiation is so strong that it will actually impede the function of instrumentation. With that in mind, is there any attempt to create those circumstances somewhere here close by and then test instrumentation so that we can send it there? Is that a plan in the works at all?
Yes, absolutely. Absolutely. So stay tuned, because NASA has every intention of sending a flagship Europa mission. There's no launch date yet, but they've actually chosen the instruments. Ooh. So we're really trying to do this. We are. We're really trying to. Does
this mission have a name at the moment?
It's had several names. I don't know what its official one is. And the controversy right now is, do we do what some of the congressional supporters want and try to send a lander? Okay. Or is that too many technology miracles and we're just going to fly by?
Okay. That sounds good.
That sounds great.
But this isn't going to be for a while, or are we?
No, there isn't even a launch date yet. I think we have to get past Mars 2020 and then some other budget
and
issues.
See if there's any money.
Oh God! Now see, that's where it all screws up. When you start asking for the money.
Yep.
There's no money.
And the funny part is, there's tons of money. Yeah. There's so much money.
Just in the wrong places.
Yes, exactly. Yeah. I mean, seriously, the billions of dollars that we give in tax credits to just one oil company. I mean, do you think we could do this for about $4 billion? Do you think, if I gave you $4 billion?
That's about right, actually.
Yeah?
Okay, so there you go. That's 1 year. That's 1 year of tax credits.
Wow. Okay.
Can you imagine? That's 1 year of tax credits, and we could get this done. It's crazy. Okay, don't get me started.
Okay, we won't.
All right, here we go.
How many cents per person, and it's not much. It's not much. So
that's true.
I'm just going to give you that assignment too, I think. That's
okay, I'm on that one for you. Okay, Lindy, I'm on that one. All right. Okay, here we go. I like this. Nate Carlson from Ottawa, Canada, would like to know this. How did large moons like Europa and Enceladus end up with so much water, while others, like Io, are mostly rock? So he went from Jupiter to Saturn and two different moons.
Yeah.
And that we know are water, have a lot of water.
Yeah. It's a good question.
But then when you do think about most moons, you don't think of a moon as a place with water. You think of a moon as a dry desert, rocky, crater-filled, Well,
that's because we think of our moon, and that's what we see because it's our closest neighbor, and we look up and we go, oh, it's there and it's dry and rocky and, fair enough.
Right.
But, they're all different and they're all formed in different ways. And so they've got, different origins, and therefore they're going to look different after they formed. So, I think part of the question, or the answer here is basically, I think it's the proximity of the moons to their big planet. So we take Jupiter. If you're really close to Jupiter, the effects that massive planet has on a moon are going to strip away the atmosphere, any water away from that moon. Whereas I think, am I right, Lindy, in saying like Europa's further away, so it's managed to maintain its water? Is that right?
I think there's a mixture of things. I think you're right. It depends on what the history of the moon is. Was it from a giant impact the way the Earth was? Was it accreted from material very close to the planet or from farther away? And then indeed, how does the planet affect it? Yeah. Does it have its own magnetic field that helps shield it, or is it just fall victim to being stripped of everything by the magnetic field of its larger planet?
Okay. So all those things come together to pretty much determine, whether or not, and that's why you see it. Like I love the fact that he used Enceladus along with Europa.
Yeah.
Because now we have two different moons, two different planets.
Yeah.
And they do share those characteristics.
Exactly. Yeah.
Cool.
Yeah.
All right. Hey, Nate Carlson, man, nice question, buddy. Nice question. All right, let's go to Anna Magnus. Mangus. Sorry, not Magnus. Mangus. All right. It's a Mangus, baby. All right. Anna wants to know this. Hello, this is Anna from Phoenix. Given the fact that we only see life-sustaining water in a few places in our solar system, how likely is it that in other solar system galaxies there is water like we have on Earth?
Oh, yeah.
Oh,
Okay.
great question.
Yeah. we agree on that.
Both. Oh.
Like, where can we start?
You say, Anna, good job, because I've never, like, both of them got excited at the same time, so that was a
know.
damn good question.
Okay,
Go
Lindy,
ahead.
you go ahead.
Okay. First of all, yay, Phoenix. That's what I mean, I have to say. This is something I'm really obsessed with.
Obsessed.
Does the water get built into the planet through its normal process of building up to planet size, or does it have to get added later? We used to be taught that the Earth got its water from comets that struck the surface after the Earth was pretty much completely made. And now we have lots of evidence that that's not true.
Oh, really?
Lots of evidence that the water on the Earth came from rocky material, the same rocky material that built up the bulk of the Earth. And if that's correct, it's not that later water wasn't added. I mean, we still have stuff falling to the Earth today and adding water. But the point is, it wouldn't be necessary. And so if it's true that the Earth was born wet, then that means that rocky planets everywhere in the universe have a very good chance of being born wet.
Ooh.
And then the question becomes, how long can they stay that way? There's some lifetime to habitability, and it's not going to be long enough everywhere.
Let me just say that that will be the name of my first erotic rock and roll album, Born Wet. Secondly, if you could please tell me how you get water from a rock aside from being Moses. If you could please tell me when you say that you think the water was built into the rock. What?
Yeah, okay.
Can you explain what you mean by that?
The thing is, the Earth was really, really hot to start with. So this is what I don't understand about these theories, although I've read Lindy's papers, obviously, but it's still hard to understand how we would trap all that water in the Earth when it was, thousands of degrees Celsius.
Right.
Yeah.
Because water is volatile and it's going to evaporate away. So how do we keep it in the Earth if it, went through this?
So water, we think, was delivered in crystals that had water trapped inside the crystal, like mica. There's a mineral that a lot of us have played with. And it turns out that there are water molecules actually trapped inside those crystals.
Holy crap.
So it doesn't come as ice, and it doesn't come as liquid water. It actually comes as rock, which is kind of crazy. And so then it also turns out it's really hard to dry things. Even if you melt that rock, and even if you melt it and raise it up to thousands of degrees, there's still going to be a little bit of water stuck in that liquid magma, because water just doesn't go away that easily. It likes to hold in. So people say to me, how can that be, right?
Yes, it
doesn't make sense, really.
But it's fascinating. I mean, honestly, as a concept, it really does. The crystal itself is holding the water.
It's holding the water.
But to unlock the water in the crystal, because the crystal is a crystal, you would have to superheat that crystal to release the water molecule.
And if that didn't happen, then you can retain that water in the Earth, and then it can stay there. And then still water can come in from elsewhere. Right. Meaning the water we end up with is a bit of a mixture of potentially different sources, but actually, some of it was there from the beginning. Now, unfortunately, we have run out of time on this question. I know. We can come back.
All right, good. We got to come back
because there's plenty more to be had here. But for the time being, we're going to take a short break, and we'll be back shortly. And welcome back to StarTalk All Stars. I am Dr. Natalie Starkey. I still have Chuck Nice with me here and Lindy Elkins-Tanton joining us from Arizona.
Yes.
Back to the cosmic queries.
Back to the cosmic queries. Now, we had to take a little break, but I really did kind of step on a Mongus's question when I interjected my question about the crystals. But let me just give her the proper due.
Okay.
Okay, because here was her actual question. Given the fact that we see life-sustaining water in a few places here in our solar system, how likely is it in other solar systems and galaxies there is water like we have on Earth? So that's the real crux. We got off into the crystals and that whole deal, and which is fascinating.
It is,
but
and it's important
and very important. But please go ahead and finish Anna's question.
Okay, so Lindy. Elsewhere, I think you alluded before that, yes, it's quite likely in the way we think the water in Earth is present, but it was trapped from the beginning, that actually this could happen lots of times elsewhere all throughout the universe. But have we seen any yet? Have we actually detected it?
hints of what's in the atmospheres of exoplanets around stars far away, but only about 12 of them have had any part of their atmosphere measured yet. So that's really an unknown area for us. All we can really do right now, besides work on making those measurements, is learn more about how water is delivered to our planets here in our solar system.
Yeah.
Cool.
That is it. These things are very far away, but I strongly believe there is life elsewhere in the universe, and that because there's water, I think there's just got to be. This place is so huge that, it's unimaginable, but I think it's got to be there.
Now, a couple of years ago, I saw this, I read this article, and there was a discovery, and it was more of a postulate than a discovery. That there may be, when we consider all of the galaxies that we know, and now with the information that we have from the imaging that's coming back, that there might be as many as 600 million planets like Earth.
Wow.
Is that true? And
Yeah.
Yes, that is true. Cool. So
That is exciting.
That's very exciting. And so with 600 million planets like Earth, what does that do to the likelihood of life and even sentient life?
Yeah, I mean, it's a huge number to even imagine. This is it has to be that there has to be life somewhere else. I'm just absolutely sure of it. When we say they're Earth-like, we should probably explain why they're Earth-like.
Yes.
Because we basically, to get an Earth, we need a planet orbiting a star it's kind of the right distance away from the star. And it's got to be the right size star, so it's not too hot, not too cold, and that this planet is at the right distance that it could have liquid water on its surface, but it probably needs an atmosphere there to contain it, probably needs a magnetic field to keep it kind of safe, and therefore it's kind of what we call the Goldilocks zone. So this is, the porridge, the oatmeal, whatever you call it here.
Oh, it's porridge.
It's porridge as well. Not too hot, not too cold, just perfect, so that we have the really good conditions like we have on Earth. So these planets exist, and there's a lot of them. It's hard finding them, but they're there just because they're so far away. But yeah, there are a lot of them. I think they've got to contain life. What do you think, Lindy? Is there life out there?
I think that there has to be. I'm with you, but here's the thing that we really don't know. I think we're pretty confident that there are really a lot, hundreds of millions, a billion planets like the Earth. But how long does it take, and how unlikely is it for life to actually start? If we have evidence here on Earth that life only started on Earth one time, even though we had the perfect conditions,
right?
Does that make it less likely? However, I'm with you. There has to be life out there.
But we don't yet know if there isn't life elsewhere in the solar system. I mean, that's the thing. There's not complex life. Right. So we know that because I think we would have seen it by now. But, we're still looking on Mars. There might have been life in the past.
And the other thing that we have to take into consideration, though, is that there could have been life and it could be gone.
Yes, exactly.
Because our solar system will one day be gone.
Yeah.
So there is very possible that another solar system with the same type of conditions as an Earth planet like ours came along. And now we're looking at that system as a part of a black hole somewhere.
Yeah, exactly. So that is, Okay,
all right.
It's a scary thought. That'll be us.
I'm not going to worry about that because I got a feeling that it might happen after I'm gone, and I'm that selfish. Speaking of selfish, here's a great question from Travis Sheaves.
Okay.
We're going to bring it back to Earth. I know both of you are, concentrated on space, but when we're talking water.
Earth is in space. It's all the same. We've got to look at the Earth to understand space.
Okay. All right. Earth is in space. I'm going to remember that. Keep remembering that because that's a good one. Earth is in space. Travis says there's one big issue facing humans, especially in the third world countries, is access to clean drinking water. Is there a way to possibly manufacture water through chemistry, or is it just not as simple as throwing two hydrogen atoms together with one oxygen atom? Is it even possible to create water, or is there a finite amount available on Earth? That's a great question.
That is a good question. And, it's a huge problem for when we want to explore the solar system, because if we're going somewhere else where there's no water, then we need to take it with us, or we need to pop by a comet or an asteroid on the way and, get some water from it, melt it, take it with us because we need water and humans are not going to survive very long without it. So if we want to go to Mars, that again is one of the big challenges for having humans on Mars, because to get water off the planet is hugely expensive.
Right.
It's not very efficient to get, to launch stuff into space. So this is a big problem. We need to find a way to either mine it on these planets if there is any water, but most of them are bone dry. That's a big problem. But in terms of the Earth, we have enough water. It's just in the wrong places most of the time, if you know what I mean. It's like
Right.
Right,
exactly.
I don't think we need to find a way to manufacture it. It's more of a way of getting clean water. We have a lot of salt water, but it's getting the clean fresh water in the right places. Lindy, do you have anything to add?
I just agree with you completely. There's plenty of water, but too much of it is dirty or too much of it is salty, and we don't know where to find more clean water. And making the dirty, salty water clean is expensive.
Yeah.
But you can make water, and I was so excited when I did that in the lab the first time. We were doing experiments in these little tubes, and inside the tube was hydrogen. And if you open the tube and the hydrogen started to burn, it makes water, because when you burn hydrogen,
You add oxygen.
You're oxidizing it,
Yeah.
it becomes water.
Wow.
And somehow making it and seeing the drops of water fall down was kind of mind-blowing to me, because you do it hypothetically or like in your head, but this was for real. We were burning hydrogen and making water.
Yep, and this is why she's a scientist, because we find these kinds of things interesting.
Oh, that is very interesting. I mean, honestly, you're burning hydrogen to create water.
That is crazy.
I mean, that's
Yeah.
crazy. That's basically a James Taylor song. You know what I mean? That's really what it is. So.
Just about emotions. It's all about emotions.
Yes, exactly. So, wow. So now, the fact that you've done this in a lab, if we ever got to a place where we actually had to create water, and this is what he was saying, we would be able to do that, as Travis wants to know. We would be able to create water out of nothing.
I guess so. And I think, didn't they do this in The Martian? I don't know.
Yes.
Wasn't this Matt Damon was up there doing this?
That's
It went
exactly
a bit wrong, didn't it? But when you're burning hydrogen, you got to be a bit careful. But
Yeah. Okay. Hey, Travis, great question, man. That was very, very cool. And let me put an addendum on his question. So, you talk about salty water being in the wrong place. You talk about salty water, you talk about dirty water.
Yeah.
Now we'll never run out of water, ostensibly, because 3/4 of our planet is water.
And we have a water cycle.
And we have a water
Everything goes
cycle,
round
right? And our
round
ecosystem creates the water cycle.
Yeah.
Is there a way, if we stay on our current course, that we would actually dirty enough water that we will run out of water? Is that possible?
I don't know. Yeah, I guess. Yeah. I don't see why not, because we're not very careful with it. And I guess at some point, we'll have to find a way to make all the water clean, and that will be hard. But we can desalinate the seawater. It's really expensive, and it takes a lot of energy to do that,
right.
which is the main problem. I have no idea, Lindy.
Yeah, and so the simple answer is yes, because there's a finite amount of water, so you could make it all dirty. But the thing that I learned recently that really shocked me is most of the water that we get is from wells. It's from underground water,
Okay.
aquifers.
Right.
Not only do we not know how much water there is in aquifers on the Earth, almost none of that is legislated. Governments don't control how much water you take out of aquifers almost anywhere. So we don't know how much there is, and we're not tracking it and taking care of it.
Wow.
That's worry.
That's worrisome, to say the
I
least.
didn't know that till just
didn't-
recently.
That's a crazy. So what you're saying is there's no regulation on the amount of extraction, but there's
A lot of places.
but there's also no effort to measure how much is actually there.
People are beginning to work on it, but we haven't gotten there.
Wow, that's I'm just going to say that's really stupid, but that's just my opinion. Okay.
We're trying to grow up as a civilization. We're trying to grow up. We're in a sort of an awkward adolescence here, but
All right. Hey, well, Travis, that was a great question, man.
Yeah.
Really enjoyed that. All right. Here's a simple one, and this is Tom Ricks from Western Australia.
There's never a simple question, is there, though? There's no stupid questions,
Well,
but
let me just say this is a short one.
Okay, it's a short one.
I don't know if it's simple. Not sure if it's simple, because our listeners, they're not simple people. Okay.
True.
Tom Ricks wants to know this: Is a comet or is comet water salty or fresh? And can we find out?
Oh, okay, that's a nice question.
That is a nice question.
Yeah. So, we can find out definitely because we can go and measure the water. It's in the form of ice, so we have to be able to measure the ices. But this comes off as vapor when the comet goes via the sun and gets heated up. So we can measure either vapors with telescopes, or we can send a space mission and go measure these things. So this is definitely something measurable, and we do it. In terms of fresh or salty. I'm going to hazard a guess it's fresh. I should probably know this. This is embarrassing. Lindy, do you... I'm going to pass this over.
Lindy, save me!
Help!
Okay, ready for this? I'm going to hedge. This is called hedging.
Okay.
So if you had salty water and you froze it, the ice would be almost entirely fresh. And so since the water didn't start as salty water and it's frozen, I think it's mostly fresh. But it's dirty. Because there's all kinds of other ices, and there are lots of rock fragments and bits of minerals, and lots of organic matter, lots of complex hydrocarbon biological building blocks kind of stuff. And so if you took a whole comet and you melted it, you would definitely not want to drink it.
Yeah, it would taste.
Speak for yourself, Lindy. Okay?
I'm talking about
All I'm saying is I can't wait to drink it.
We don't just have water ice on these comets. Because of where they formed, it's super cold. You can get other weird types of ice as well, like methane ice.
Right.
And so you've got a whole mixture. So yeah, if you could just get the water ice itself, you'd probably be all right. But I'm not sure I'd want to be drinking all the methane water and stuff.
Because there's a lot of things that once you get to a certain temperature, they'll become ice.
Yeah, anything.
A lot of gases that will become ice at a certain temperature.
Exactly. Yeah.
Okay. So and all that's mixed in. And when you say mixed in, are they mingled, or are they mixed in as in you have one type of ice next to another type of ice?
I mean, it's probably a bit complex because you've got the dust in the comet, and these are all kind of fine-grained bits of rock, kind of small pieces of rock, just the dust that form the solar system.
Right.
But mixed into that, you've got organic material, which we kind of say it's kind of gloopy. It's like
gloopy. That's a nice
kind of,
scientific term that I like.
It kind of holds stuff together. It's like a glue to hold these dust particles together. Otherwise, the comet, it wouldn't just fall apart because there's not much acting on it to make it fall apart. But this helps us stick the stuff together. And then we've got the ices. Now, in terms of understanding the distribution of those ices through the body, I don't think we have a good idea about that at the moment. But the methane ice forms what we call a clathrate. It's kind of a different structure. It's got a different structure to normal ice. And that can actually, have bits of other material in it, but you then have the water ice as well. I think, they're probably closely associated. But it'll depend on the particular area of the comet. But it will be dirty. It'll contain a lot of the dust and the organic materials. So,
cool. Very cool. I don't know why, but every time you said ices, I had a patriotic urge to kick that comet's ass. I'm sorry. I'm sorry for that. Everyone, please, I apologize. All right.
Have we got a quick one?
Okay, let's get a quick one. And see, I said it was short, and you're right. It wasn't simple.
It wasn't simple.
It was a short question, but it really wasn't simple. All right, here we go. This is Heidi Heimler, and Heidi says, are there any indications of possible life forms in the rocky material that may be the source of water on Earth? So that's kind of let's see, and I said simple.
Great question.
That's a really cool question,
Okay.
and I don't know that certainly I don't know if we got time for it, but that's a great question.
Lindy,
are there any indications of possible life forms in the rocky material that may be the source of water on Earth? A lot of stuff packed into that question.
Okay, so I think what we can do, this is a great question. So Lindy, do you want to start answering this question?
Yes.
We may run out of time in the segment, but we can come back because I think there's probably quite a lot to say. So yeah.
So the short answer is no, there's not.
What?
But why not? We don't know why not. And so actually, we're teaching a whole course about this in the fall to try to begin to understand why not, because no one knows.
Yeah.
Wow. We did have time for that question.
We had time, but then why? This is some of the questions we've got to ask.
Okay.
And it should be. So it's a really good question.
It is a good question.
We can leave it there.
And
we're going to take a short break, but we'll be back with StarTalk All Stars shortly. Welcome back to StarTalk All Stars. I am Dr. Natalie Starkey. I'm still here with Chuck Nice and Lindy Elkins-Tanton, and we are getting some cosmic queries about water in the solar system. We've had a great time so far trying to understand this complex subject. So you're going to...
Let's move on.
With another question.
Let's hit you with another question right here, okay? I'm still reeling from the crystals. I'm telling you right now.
Wet rock.
Wet rock is like freaking me out. And by the way, for those of you listening and watching us here on our video of Connect Pal, please look for my new erotic rock and roll album, Born Wet, named by Dr. Lindy. Okay? Thank you very much.
I want licensing fees on that.
All right. Let us move on. And this is Jalen Paxton. And Jalen is coming to us from Twitter at Jalen Paxton. And Jalen wants to know this. What is the feasibility of using comets to combat freshwater shortages on Earth in the future? We kind of touched upon this a little earlier when you were talking about the ices on a comet.
And actually, no, I mean, it's a good question because they do contain a lot of water, but actually asteroids also contain a lot of water. In fact, they could be, tons and tons of water on asteroids, more than in the Earth itself. So, and they might be easier to get to because we have quite a lot of near-Earth asteroids which are close to us, which we can get to quite easily. But I think, as we've said earlier, it would be more useful to use those to go elsewhere in the solar system because we, don't have a huge water problem on Earth at the moment.
Right.
So I think if we want to go to those and mine the water, we can split it and use it for hydrogen fuel, or we can use it to drink or to survive. There's even talks about the best way to protect yourself in space is from the radiation, I think, is to coat a spacecraft in a kind of volume of
bubble of water. Like a womb.
Yeah.
A space womb.
Exactly.
Oh my God.
A little protection bubble.
Oh, it's so safe.
Back to your album.
Yeah, that's my second album. Space womb.
So this might be a way to do it, use the water from these asteroids or comets, but it's just, they both contain the water. But actually...
The asteroid is probably a better choice because you might find more water.
Just easier to get to, maybe.
Easier to get to and more water.
There's more of them nearer to us, so yes, that would be better.
All right, very cool. Very cool. Let us move on.
Oh, God.
I'm just laughing at the name. Electronic janitor.
Is this from Twitter?
This is from Twitter.
Is this a Twitter handle?
At Electronic Janitor.
Nice.
That's a very cool handle. Something tells me he's an IT guy who really hates his job.
That way.
He wants to know this. Where other than Earth have we positively identified water like we have here on Earth?
Okay, but we have tons of different types of water on Earth. So I guess we've got fresh water and we've got salt water.
Salt water, fresh water.
So loads of places. It's everywhere.
It's everywhere.
Just it depends if you want it as liquid or not. But right. I mean, we think there is liquid in loads of other places. So yeah.
So now here's what I want to know, based upon his question for you and Lindy. Ice seems to be the order of the day because space is really, really cold.
Yeah.
But where does the ice get to be ice? Because it had to be someplace hot and something else before it became that ice on the asteroid or the comet.
Okay.
So where does that happen?
Where does water become the ice water?
Right. Well, what is that? Is that in the formation of something, or what happens to make that happen?
Okay, Lindy, do you want to?
Sure. I can tell you what our best idea is, although I don't think we really understand this process yet. But it looks like when planets are forming, they start out just as a rotating disk of gas and dust around the young star. We see this elsewhere in the universe, even though ours is long gone. And close to the young star, it's too hot for the water to be ice, but further away from the young star, ice is formed because it's cold, even in that early dust and gas disk. And so some of the ice could have been ice from the beginning of the solar system, and it was never melted and then frozen again.
Oh.
There we go.
Look at that.
Primordial. So if we captured a comet, we could drink primordial ice from the origin of the solar system.
So this is like 4.5
That sounds like a
billion
party.
years old.
That's a party I want to go to, Lindy, by the way.
I know, that's good.
Yeah.
A little vodka.
Yeah,
I think-
that's what I'm saying. You know what I mean? Just like, a little Kettle One and Primordial Ice.
Primordial
Yes.
ice, yeah.
Can I have Kettle One on Primordial Rocks, please? So that's it. All right.
And you could get the ice made of different types of hydrogen. So if you got like the heavy ice,
Yes.
then you'd get potentially ice cubes that might sink in your drink rather than float.
Nice.
Yeah,
All
this could be
right.
fun.
Yo, this is fun. I kind of like
Could
it.
really charge a lot of money for that.
Yeah.
Primordial ice. Yeah, they're lining up right now.
All right, very cool, very cool. Okay, this is Chris Jacobs coming to us from Twitter. And Chris wants to know this. Do you think we'll be mining from asteroids or meteors in the very near future? It's a good question because we have now landed with Philae.
Yeah.
So how far are we from actually going in and mining?
Yeah, that's really debatable because, I mean, it's something that it's kind of come to the forefront in the last few years. And there's a couple of kind of private companies that are now looking at actually doing space mining. Now,
Really?
Originally, I think they were saying it was going to happen really soon. And I think as scientists, we all stood there going, wow, okay, they're going to do this really quickly. And that's going to be very, very impressive if they can do it. And I think their plans have been slightly scaled back when they realized that actually it is going to be a little bit trickier than they thought. They've got to get the funding together. But the potential is that if they were to be able to mine these things, the return economically is enormous. So a small investment to start with, we're still talking billions of dollars,
Right.
but you could potentially release many, many more billions from these asteroids. If you
And
bring
that's
stuff
because, of course, you being a geologist, inside of these asteroids are the same elements that we find here on Earth.
Exactly.
Which means the rare elements, the ones that are really expensive,
Yeah.
we might be able to find crap loads of
There's
those.
so much up there. And, quite a lot of the precious metals are so important on Earth for making a lot of our electronics.
Right.
And there's a finite amount on Earth. We're going to use it up. It's in seams and stuff, and it's concentrated in different areas, and that's why we mine in different areas on the surface. But with an asteroid, there's tons of this material. So the potential is that there's every potential that we can mine these things, but it's just going to be a case of time and economics. And then we've got to decide how much we need, say platinum, how much we need the platinum. And if we've run out on Earth, what price it's got to on Earth, and whether it's going to be economical to go into space and make this happen. So I think it is going to happen in the future. And I think it's going to be a case of, hopefully, what I hope is private companies working with space agencies so that we get some scientific return from this, but we also get whatever we need economically. So, yeah, do you have anything to add, Lindy?
Yeah, I can't resist. So they are thinking, they've got even models for how they could go to a rocky asteroid, take some of that miracle water that's trapped in the minerals and heat it up to release the water. So it's feasible. It's not economically viable yet, like you say, but the thing I like to think about, we're trying to go to an a metal asteroid right now with a mission to look at it. And if we could bring that back to Earth, you're right, it would be the equivalent of all the metals we've ever needed. But then you don't really make billions and billions of dollars because what you do is you collapse the global market.
Yeah, because suddenly you have too much of it.
Right, because from an
It's an
economics
interesting question.
from an economic standpoint, if we had a crap load of gold here on Earth, gold would no longer be valuable.
Yeah, so
Exactly.
we'd have to kind of
Exactly.
retain it. So there'd have to be, organizations that retained it and released it as we needed it. Otherwise,
Yeah, you
there'd
would
be no
have
cost to it.
The fact is, you would own the asteroid, and then you would release the gold as necessary. So you would
Yeah.
basically corner the market.
Yeah.
On whatever it is, platinum, gold, or whatever it is. And then you would determine how much you're going to release to set the price for it.
And then there's other problems with who owns this stuff because it's space. We understand Earth, we fight
That's right.
over who owns bits of the Earth, and that's bad enough. But we're going to space. Well, who owns the stuff? So if a private company goes up, a US company, is it a US asteroid then? Is it all US resources, or is it the global?
All I know is if I land on that asteroid,
It's yours.
that's my asteroid. And if you think it's not, you can kiss my asteroid, okay?
Very good.
Okay. Let's go with Lucas M. Rodriguez, and he wants to know, which of the two icy moons is more likely to support life, in your opinion, Europa or Enceladus?
Oh, that's a good one.
Okay, so which one of those two moons from those two planets is more likely to have life?
That is so. Do you know, I could not decide actually between those. They're both quite. I'm going to say highly likely to. They've got the right conditions almost. So I don't know. Do you have an idea? I don't know. I think both could.
I can't immediately think of a reason why one would be more likely than the other, but the thing that troubles me about it is that the very most likely place for there to be life on them is at the bottom of the water ocean next to the rock.
Okay.
And how we will ever detect that, I don't know.
Well, I mean, can we just... So we've got to get through the ice. They've both got an ice layer, I guess, on the outside.
Yeah.
So we've got to get through the ice with some kind of spacecraft and drop it in and then get to the bottom of that ocean. It's not very easy because if it's deep, we find it hard to get to the bottom of our ocean.
We can't even get to the bottom of our own ocean.
So the pressures are crazy. The conditions are going to be not very conducive to, getting, to get transmitting a signal back and to understand what's there. So yes, I guess it's going to be hard for us to tell.
Yeah, well, there you have it, Lucas. You have just given our two scientists a Sophie's choice. They cannot decide. Okay, both my babies must die. I can't decide. All right.
Yeah.
That is fantastic. What is our next question? We'll come.
Okay.
Wait, let me see, because I know we're running out of time. And
We are.
I saw a cool question from someone from the United Emirates, and I just lost
cool.
it. Oh my God,
People are listening everywhere.
Yeah, people are listening everywhere, and that is what is so cool.
And
All right, I can't.
you can't find.
I can't. Oh,
upset.
damn it! I'm so sorry. I just marked it, and I can't.
I know it's gone.
Oh my God! And there's only 3 pages here. It's not like what the hell just happened to me? Oh my God, ladies, I'm having a stroke.
Oh, it's got to be there.
Yeah, that person is sad.
They have to get a question.
Yes.
Mention them.
Keep looking. Keep looking.
Oh my God! What they wanted to know was, can we make a substitute for water? That's really what the question was. But
Okay. So
can we make a substitute for water so that when we are traveling to someplace else, instead of having a way station, can we make a substitute for water for both here on Earth and for space travel? And I'll look for their name while you guys answer that.
okay, but I guess yes. Okay, I get the question, but it's understanding like why we need water and what water does on Earth. And water acts as a solvent, and it's basically allows us for reactions to happen.
Okay.
There are other solvents as liquids that can exist in the solar system that could do the same job, but we wouldn't be able to drink them or survive on them. But that doesn't mean that other life forms couldn't, but we just haven't seen those life forms yet. We have just a little bit of time. Lindy, do you want to add anything to this?
No, I think you nailed it. There's nothing else that will do it for people but water.
Yeah.
So water is it. I mean, we could make a substitute, but why would you? Right?
Yeah.
That's really the deal.
Exactly. But it doesn't mean that other organisms elsewhere, alien organisms might not need water. That's the thing. But they need something that's liquid that is not going to boil away and not going to freeze too easily, that they can survive in and form in.
Gotcha. And by the way, it came from, here's the name, Shirag Jangla. From
brilliant.
Dubai and the United Arab Emirates. That's who gave us that question.
And they've got, quite a lot of desert there, not much water going on there.
Can you just imagine why someone from Dubai might ask a question of, can we make a substitute for water?
I know.
Because I'm so tired of eating sand.
They've made a city out of sand. But I'm afraid that is all we've got time for. We are at the end. I know. It was fun. It was a whirlwind.
Yeah. And
I had
Lindy,
lots
you were
of fun.
Great.
Yep. Thank you so much, Lindy.
I really enjoyed this. Thanks so much.
You've been great. You've helped me with some tricky questions.
You had great answers. I was just nodding my head.
Oh, well, I'm pleased. Thank you. I feel happy. But thank you so much. And I'm going to thank Chuck Nice, my co-host. You've been fantastic.
Pleasure.
But that's, all we have time for today. But that's been StarTalk All Stars. I am Dr. Natalie Starkey.
This is StarTalk.